Good afternoon, everybody. Hope you are doing well. So today we will discuss about game theory inside the oligopoly market. If you recall, we have seen that when only firms in the market, the decision of the manager is would be based on others managers' decision, and we have seen that how managers would choose or decide their price based on their rivals and also the quantities produced. So one of the tools that can help managers in deciding on what strategy that they have or they should do in order to maximize their profit in considering the other rivals' strategies or action is the game theory. So today our topic will be on game theory. We will have first an overview of the games and strategic thinking, simultaneous move, one-shot game, and we have infinitely repeated games, we have finitely repeated games, and multi-stage games. So what is the game theory framework? A game theory is a general framework to aid decision making when an agent payoff depend on the action taken by other player. Means that any decision that a manager should do or want to do is not based only on his decision, but is based on others. So his payoff or his profit will be also based on the rival's decision. So for that, the game theory consists of the following component. We have the players or the agent or the managers who make a decision. We have the planned action of the players, or we call them strategies. And we have the payoff of the player and the different strategy scenario, or you can call it as a profit or revenues, or losses or profit. So we have a description of the order of the play, and we have a description of the frequency of the play. What is the description of the order play? So the order of decision in the games, we have simultaneous move game, where the game in which each player make a decision without the knowledge of the other player's decision. Means if I want to increase the price, I don't know what my rivals or my competent is going to do. Is also going to increase the price or decrease the price or maintain the prices same level. And we have sequential move game, which is a little bit easier. This game in which one player makes a move after observing the other player. If I want to increase my prices, first I want to wait until to see my opposite opponent or my rival what is going to do. He's going to increase in the price, therefore I will increase. If he is going to decrease in the price, then therefore I'm going to also to decrease the price based on his move. Then we go to the frequency of interaction in games. We have a one-shot game in which player interact to make a decision only once. Means that only one time just to make your decision. Once you make a decision, you cannot have another decision, or you cannot make another game. But we have a repeated games where here the game in which the same player interact to make decision more than once. So I may make decision A, after I will make decision B, or I continue making the same decision A, but this will be repeated for many times. So what is the one-shot game theory? The strategy, a decision rule that describe the action of a player that we take at each decision point. So I may have strategy A or B. I may increase my price or decrease my price. I may have increase in my advertisement, or I decrease it. A normal form game, which is representation of a game indicating the players, their possible strategies, and the payoff resulting from alternative strategies. Let's see, this is here. So we have this table Then you can see here player A and player B. Player A has strategy up and down, and player B has strategy left and right. And also player A possible payoff from the down strategy, either it is -10 or +10. In the up one it will be +10 or +15. Player B possible payoff from strategy right, this will be 8 or 10, and from strategy left will be 20 or 7. So what are the possible strategies? We have so many strategies. This comes by asking the question, what or how manager should decide what strategy to follow. So here, first we will discuss about a dominant strategy, a strategy that results in highest payoff to a player regardless of the opponent action. Means that whatever my opponent or my rival action is, strategy is following, I secure the highest payoff. That way I call it my dominant strategy. Then we have a secure strategy. In a case that one player does not have dominant strategy, then what he should do? He may think of the secure strategy, a strategy that guarantees the highest payoff given the worst possible scenario. Means that what is the most possible scenario that I can face? This is the highest payoff that I can get, and this is why I secure my payoff. And the last is the Nash Equilibrium strategy, where it is a condition describing a set of strategies in which no player can improve her or his payoff by changing her or his own strategy, giving the other player's strategies. Means that when I choose a strategy, there is no incentive for me to change my strategy as I already have achieved the highest payoff. So that's what I can get maximum. This is what the better payoff that I can get. So there when I reach Nash Equilibrium. So let's go here and see the first one, dominant strategy. So as we say in this table, we have two players, player A and player B. Both of them, they have two strategies. The player A has up and down, and player B has left and right. So what will be the dominant strategy? For player A would be up, of course. Why? If you ask why, let's see. For example, if player A choose up, player B either he choose left or right. Correct. So if player B choose strategy left, then player A strategy in the up, he will get 10. But if player B choose right, he will get 15. But assume that if player A put down, so if player B choose left, he will get -10. But if player B choose right, he will get 10. So you can see from this, player A is dominating the up strategy. Means that if he choose the up strategy, whatever player A he play, he still get the better off, which is either 10 or 15. But here he can get only -10 or 10. So what is the highest payoff is if choosing up strategy. And what is the strategy for player B? You may think. So the answer is player B has no dominant strategy. Why? We assume that if player A choose the up strategy, so player B, he can either choose left or right. If he choose right, it is better for him to choose the left, he get 20. But if player A choose the down strategy, then player B either he choose left also and right. If he choose left, he would get only 7. But if he choose right, he may get 10. So you can see here, player B does not have a dominant strategy. Means is that his payoff is changing depend on the changes of player A strategy. Then in that case, what would player B do in order to secure or to guarantee a payoff? In this case, we come to the second strategy, which is secure strategy. How it works? You can see here, if I ask you, what is player A secure strategy? When you can see here, you will know that it is up. Why? Because it guarantees at least 10 payoff. Means that whatever player B play left or right, so the player A, the minimum that he can get is 10. It's secure, right? So, but if he play down, he may get minus 10, and the maximum is 10. So by playing up, he guarantees this 10. But what is for player B? For player B, the secure strategy is right. Why? Because he will guarantee the 8. Whatever player A playing. Let's say, if player A play up, he guarantee 8. Either he get 8 or 20. So the one that he guarantee in the worst scenario is 8. But if player A play down, he may play 7 or 10. So here, if he choose left, he get only 7. But he choose right, he will get 10. So to guarantee, or the secure strategy that guarantees for him the highest payoff in the worst scenario is 8. Whatever player A choose, this is the worst scenario or he can get. So if player A choose A, he can get 20 or 8. He secure the 8. But here, if player A play down, he can get 7 or 10. So he will secure 10. So which is the minimum is 8. Therefore we say the right strategy here is the guarantee or secure strategy for player B, where he guarantees at least a payoff. Now, what is the Nash equilibrium as just now we described? Here a Nash equilibrium result when player A plays up and players B play left. That means this 10-20. Why? Because you see here, if player A chooses up, correct? Then player B, what is the highest payoff for him? Of course, he will choose 20. Correct? But if player A chooses down, then he will have here minus 10 or plus 10. And player B, he may have plus 7 or plus 10. So if player A chooses down, this strategy is not a strategy where the player A has the highest payoff. He can change his decision by playing up, and therefore he get 10 or 15. So when he put this strategy, the up strategy, he has no incentive to change to the down one. So for the player B, either he choose left or right. Okay, by choosing the left side, he may get 20 or 7. If he choosing the right, he may get 8 or 10, depend on player A. Since the player B knows that player A has a dominant strategy which is up, so it is more likely that player A is playing up. Therefore, he will choose the left, because if he chooses the right, he will get only 8. And player A will get 15. So since you know that player A has the dominant strategy which is going to play up, therefore he will choose the left, and this will be the Nash equilibrium. I want to record back for the previous one, a secure strategy. Even though the secure strategy guarantees the minimum or the highest payoff in the worst scenario could happen, but it is not a very good strategy that would follow. Why? This is because in this case, as we say, player B secure strategy is right? Where he can secure at least 8. But if player B knows that player A dominant strategy is up, in this case, if he play right, he will get only 8 and player A will get 15. So, by right, if he choose the left side, so the player B he can get 20 instead of 8 and player A will get 10 instead of 15. So here, if player B play the secure strategy to guarantee the highest payoff that could get in the worst scenario, then he will lose almost 12 units of payoff, because he should know that player A guarantee strategy is up, therefore he play the left. So this is one of the limitations of the secure strategy. Then we come to this application of one-shot games pricing decision. Here, suppose there is two companies or two firms, firm A and firm B. And firm A has either to choose a low price or high price, and also firm B the same. Now, if firm A choose low price and firm B choose low price, both of them they will get 0 payoff. And if both of them they choose high price, they will get each one 10. If firm A choose low price and firm B choose high price, firm A will get 50 and firm B will get minus 10. That's mean lose. This is why, because since firm A choose lower price, all the customer of firm B will buy from firm A, therefore you will get more profit. And the same here. If firm A choose high price and firm B choose low price, so firm A will lose 10 and firm B will make a profit of 50. So this is why, because all customer of firm A will goes to firm B and buy from it. Now, how we are going now to decide the Nash equilibrium? Nash equilibrium in this case result when both players charge low price. Why? Because none of the firm will charge higher price. If they charge both of them higher price, they will get 10-10, which is better than 0-0. But they will not do that. Why? What if, let's say, firm A choose high price, but firm B cheat and choose low price? Of course, firm A will lose. And the same for firm B. We think in that way. If I choose the low price and firm A choose, if I choose the high price and firm A choose a low price, then firm B is going to lose. So this is too risky, unless if they come to a collusion. They colluded or make an arrangement and say that both of us, we charge high price, and therefore they can get both of them 10 and 10 of payoff. So who lose here? The consumer will lose because he's paying higher prices. So as we say, a Nash equilibrium result from both players charge is the low price. Payoff associated with Nash equilibrium is inferior from the firm's viewpoint compared to both agreeing to charge high price. Hence, is a dilemma. So you may ask why companies may not collude or make an agreement. The answer for this is for two reasons. The first reason is that colluding is illegal in most of the countries. And because companies are not allowed to make an agreement to charge higher prices. And the second thing, if let's say there is a secret agreement between the two firms and the managers colluded and decided or agreed to charge a high price so that they can get both of the firm 10-10. So what happened is that if one of the firm cheat, let's say firm B cheated, then firm B will get 50 and firm A will get minus 10. So now the board of directors will ask the manager, why our company lose minus 10 but our rival gained 50. So now the manager has to answer. If he say that he's been colluded and been cheated, he may go to prison. Correct? Since it is illegal. So he may not, do that, so that he will not be in that situation. Therefore, this collusion or collusion between the two firms to charge both of them high price may not happen. So we come to this low price, both of them charge low price and get zero of the profit. Now we have an application of one-shot games, coordination decisions. So in coordination decisions, we assume that we have two firms, firm A and firm B. Both of them produce an appliances or electrical appliances. So firm A may produce 120 volt outlets or 90 volt outlets, and firm B also may produce 120 volt outlet or 90 volt outlet. So here, if let's say firm A producing 120 and firm B producing only 90, and those appliances, when consumer want to buy, they need to invest a lot in wiring, and this, bring in experts to do the wiring and to the electrical connections. So what consumer, therefore, they may not buy or reduce the demand for that electrical appliances. So that we can see, if both of the firms produce different voltage outlets, therefore the profit will reduce, or the payoff. Here 0 is just for illustration, could be 10, could be 50. But what if both of them agreed to produce either 120 or 90? So you can see here the payoff is 100. Therefore, so here customer or consumers, they don't need to invest a lot in the wiring and in paying expert to do the connection in the house or in the building. Therefore, the demand for that appliances will increase. And when the demand of appliances increase, therefore, so the payoff will increase. In this case, both the firms make higher profit. I just want to tell you is that this collusion could happen and is legal, because this collusion is not an agreement to charge higher prices, but an agreement to charge a particular a particular product or way to make consumer easy for him to buy appliances or to install the electrical wires in the house. Therefore, here it permits the player communication, which is the firm, and also maybe government set standard. And I think this is what in Malaysia, when you go and see your electrical plug is standardized. It's not different, like for example, one may be in China way, one in Thailand way. So this is totally different from the previous one. So again, this game theory also could be also played or could be also helpful in monitoring employees, to monitor employees. We have seen in previous topics agent principle strategies, where how agent worker principle strategies, or how the employer make sure that the worker are doing their best, and sometimes also the worker try to shirk or to work less. So how this complication happen? So in the game theory, let's say we have two players, the manager and the worker. And the strategy for the manager is to monitor or don't monitor. For the worker is to work or to shake. We assume, for example, if the manager monitor while the worker was working, so the manager will have -1 and the worker will have 1 because he was working and he was not caught. But if the manager monitor and the worker was shirking, so the manager will get 1 payoff, means that he monitored and he caught someone, and the worker will get -1 because he got caught. And if the manager do not monitor and the worker was working, so the manager will get 1 because he didn't monitor, he didn't spend time, but the worker was working. In this case, the worker will get -1 because he could shirk because the manager didn't monitor. But if the manager didn't monitor and the worker shake, then the manager will get -1. Since he didn't monitor, the worker was shaking. And for the worker, because the manager didn't monitor and the workers was shaking, so or he was not caught, so he will get 1. So what is the Nash equilibrium here? If you can see and do some analysis, you will understand that there is no Nash equilibrium outcome associated with these games. Why? How should the agent play this game? So A, he play mixed randomized strategy, because whereby a player randomizes over 2 or more available actions in order to keep rivals from being able to predict his or her action. Let's explain it. If the worker want to shake, now if the manager did not monitor, so he get 1. Correct? But if the manager monitor, he could get -1. So in that case, the worker, instead to shake, he should try to don't shake, because the manager is monitoring. So he has a better strategy. And the same, if you want to work, if the manager monitor, he will get 1. But if the manager did not monitor, he will get -1. So in that case, if the manager didn't monitor, it's better for him to work. If the manager monitor, it's better for him to shirk. So in each scenario of the manager work, he may change his decision. And this also applies for the manager. So in that way, there is no Nash equilibrium associated with this game. Now we go to Nash bargaining, and this is mostly applicable for worker union. So let's say there is a management and there is a union. So we have 3 strategies. Let's say we have 100 ringgit, and this 100 ringgit should be divided between union and management. So we assume for simplicity that 100 ringgit is either divided to 50 or take all. So union can get half, 50, or take all, or doesn't take anything and give it to the management. So if the union take 50, so management get 50. If union get 100, management get 0. If union doesn't want to take any, then management get 100. So here, if you can see, we have 3 Nash equilibrium outcome associated with this game. The first equilibrium, management chooses 100. So when management chooses 100, if the union chooses 0, then we reach the Nash equilibrium. But let's say if management choose 100 and union choose 50, here we will have 150, which is above than 100. Then in this case, we call the stalemate. So the deal cannot happen. and disagreement on that, and therefore maybe the meeting will end without any deal. So that we say that to that stalemate as -1 for each. And same if management want 100 and the union want also 100, also the summary will be 200, and both of them, they cannot come to the deal. So we'll have -1, -1. Second scenario, if the management decided to get 50 and union decided to get 0. So we will have management 50 and union 0, and we have extra 50 is not taken. But so that could be improved. So could either union change his decision to take 50 or management to change decision from 50 to 100. But if both of them they want to take 50-50, then Nash equilibrium happen. And if management want to take 50 and union want to take 100, then the total become 150, and also here we come to the stalemate and the decision or the agreement cannot happen. And the last scenario, both of them or the management will choose to take 0, management 0, and the union choose to take 100. In that case, we come to a deal. But if management won't choose to take none, 0, and union choose to take 50, it is not Nash equilibrium, because there is a possibility either union to choose to change his strategy and get another 50 become 100, or the management to change its decision and get 50 rather than 0. So that also could not give us the Nash equilibrium. So you can see this strategy 50-50 and 0-100 or 100-0 are all Nash equilibrium. So either management chooses 100, union choose 0, or both of them they choose 50-50, or management choose 0 and union choose 100. So 1, 2, 3. So 0 is not Nash equilibrium. -1, -1. These all stalemate where the deal is not happening. So now we go for the second part, which is infinitely repeated games theory. An infinitely repeated games is a game that is played over and over again forever, and in which players receive payoff during each play of the game. So disconnect between current decision and future payoff suggests that payoff must be appropriately discounted, or at least we assume it as an interest rate, because $1 of today is worth bet higher than $1 of tomorrow. So here we come again to the first topic, which is the present value analysis. When a firm earns the same profit pi in each period over an infinitive time horizon, so the firm present value will be PV firm equal pi 0 for this year, plus pi 1 divided by 1 plus I for next year, plus pi 2 divided by 1 plus I power 2 in the second year, plus pi t divided by 1 plus 1 power t in the time t. So this is equal to a simple formula 1 plus I divided by I times P, assuming that pi 0 equal to pi 1 equal to pi 3 equal to pi t. So if we assume that, therefore PV or present value of the firm equal to 1 plus I divided by I times all pi. I is the interest rate. So how we are going to support the collusion with trigger strategies? Now we assume that we have two firms. We have firm A and firm B. Firm A, as we say, either to charge low prices or high prices, and same for firm B. If firm A charge a low price and firm B charge a low price, both of them, they will get zero payoff. This is just for illustration. If firm A choose a low price, firm B choose a high price, then firm A will get 50, firm B will lose 40, because all the customer of firm B will go to firm A. If firm A choose a high price and firm B choose a low price, firm A will lose 40, firm B will gain 50, because all consumer of firm A will go to firm B. If both of them charge a high price, they will each get 10. So the Nash equilibrium to a one-shot simultaneous smooth pricing here is similar to the previous one, is 0-0, as we say. When this game, but this is only in one shot, but we assume that this game is repeatedly played. So it is possible for firms to collude without fear of being cheated using triangle strategies. Means that the two firms will come to an agreement to charge a high price, and they don't fear of any of them will cheat, because if firm A cheat, then firm B will punish firm A by charging all other times with low price. And if firm B cheat, then firm A will punish firm B by charging all other times with low price. Therefore, the trigger strategy is a strategy that is contingent on the past play of a game, and in which some particular past action or triggers a different action by player. If, let's say, from the beginning when they agreed that charge high prices and continue playing, let's say, multiple times, so they will get both of them 10 plus 10 plus 10 plus 10 plus 10 plus 10 plus 10. Correct. But if, let's say, one player want to cheat, the first he choose higher, first both of them choose high, he will get in the first 10. But the second, if one choose high, another choose low. Let's say firm A choose high, firm B choose low. So firm B will be gaining 50, while firm A will gain minus 40 in the first shot. But after that, firm A will punish firm B by charging the low price, and they will get all 0, 0, 0. So the maximum for firm B here to get is 50. By right, if did not cheat, it will get 10 plus 10 plus 10 plus 10 plus 10 plus 10. It may exceed 50. But that depends on how many times it's going to play. So to calculate that, the triangle strategy example, so both firms charge a high price provided neither of the firm has ever cheated in the past, charge low prices. If one firm cheated by charging a low price, the other player will punish the deviator by charging the low price, as I explained here, and you will get 50 plus 0, 0, 0 for the cheat. Then when both firms adopt such triangle strategy, there are a condition under which neither firm has an incentive to cheat on the collusive outcome. But again, if a firm A does not cheat, it earns 10 each period, as I explained. Thus, the present value of the profit of firm A, if it cooperate, does not cheat, will be 10 plus 10 divided by 1 plus I plus 10 divided by 1 plus I square plus, and this equal to this formula 10 times 1 plus I divided by I. So when I is the interest rate, the firm A has no incentive to cheat if the present value of its earning from cheating is less than the present value of its earning from not cheating. Why? For the number of this example, let's say there is no incentive to cheat if PV or present value of firm A who cheat equal 50 if that 50 is less than or equal to 10 times 1 plus I divided by I. And this if it is equal to the present value of firm A corporate. So which is in this case true if I equals 0.25. If we count here I equal to 0.25. In other words, if the interest rate is less than 25%, a firm A will lose more in present value by cheating than it gain. So the interest rate is very high. So if she cheat, it may lose money, not making money. So it is better for firm A to collude or to cooperate for the agreement, and therefore can get all, a higher payoff more than 50. So this is the formula where the firm A decide is going to cheat or no. If for example the interest rate is less than as we say, if the interest rate here is less than 25%, firm A will lose more in present value by cheating than it will gain. But if the present value is more than 25%, then better for the firm A to cheat, because it will gain more by cheating than it will gain. So here we go to another explanation for this, where we have suppose a one-shot game is infinitely repeated and the interest rate is I. So for the support for cooperative one-shot payoff to a player is pi cube. The maximum one-shot payoff if the player cheat on the collusive outcome is pi cheat. So the one-shot Nash equilibrium payoff in this case pi n, and here we will have pi cheat minus pi cube divided by pi cube minus pi n should be less or equal to 1 plus I, the interest rate. In this case, then the cooperative collusive outcome can be sustained in infinitely repeated game with the following target strategy. Cooperate provided that no player has ever cheated in the past. If any player cheats, punish the player by choosing a one-shot Nash equilibrium strategy forever after. So let's see this here. In this strategy, we have suppose firm A and B repeatedly play a game above, and the interest rate is 40. It's not 25, it's 40. Firms agrees to charge a high price in each period provided neither has cheated in the past. So the question, what are firm A profit if it cheats on the collusive agreement? Here, the answer, if firm B lives up to the collusive agreement but firm A cheat, firm A will earn 50 and 0 after that, because firm B will punish it and choose a lower price, not high price, and get 0. So it means maximum get 50. 50 plus 0, 0, 0. Correct? So, what are a firm's A profit if it does not cheat on the collusive agreement? Means it will remain on the agreement. So here will be each time is 10. But remember, we have to discount that amount, interest rate. So 10 plus 10 divided by 1 plus 0.4, which is 40% interest rate, right? Plus 10 divided by 10 plus 0.4 square plus, and this equals 35. So you can see in this case, firm A better or will gain more payoff if it cheats. If it cheats, then it will get 50. If collude with 40% interest rate, then it will lose. I mean, not lose, but you get less payoff. So that we say here, if you recall here, we say if the interest rate is less, in that case 25%, when we assume the payoff is 50 for cheating, the firm A will lose more in present value by cheating. But here now, since the interest rate is more than 25%, which is 40%, so firm A will lose more by colluding. So the firm is better for the firm A to cheat. When cheating, getting 50. When colluding, getting only 35. So now we come to another question. Does an equilibrium result where the firms charge the high price in each period? So since 50 is greater than 35, the present value of firm A profit are higher if A cheat on the collusive agreement. In equilibrium, both firms will charge low price and earn zero profit each period. So this is what does mean. Since firm B knows that there is a possibility that firm A will cheat in order to get a higher 50, because the interest rate is very high, therefore firm B also will charge low price, because knows that firm A will charge low price. Therefore both of them, they will get zero payoff. But if the interest rate is more or less than 25%, then firm B will know that firm A will not cheat. By not cheating, you will get more payoff by colluding and getting 10 plus 10 discounted in the first year, plus 10 discounted in the second year, plus 10 discounted in the third year. It may gain more. It will gain more than 50 payoff. So after we discuss about this, now we come to discuss about what are the factors affecting collusion in pricing games. So sustaining collusion via trigger strategies is easier when firms know who their rivals are, so they know whom to punish if needed. So my rivals are big companies, small, we can punish them or no? They have a history of that or no? How they think, who are the managers, and who their rivals' customers are, so that they can steal those customers from with lower price. But here, the problem, if you want to steal customers from another company, you are going to charge low prices for those new customers. But again, if you want to do that, if you are a retail store, when you lower the price, you should lower the price for all customers, including your own. And here you may have your P, or you may reduce your profit. So it is extremely difficult to come to in a way that you want to charge lower prices only for a new customer that you steal from the other companies. But if the manager has to do in such way, then it's good. And this is, you can find it in some teleco companies, they can do that. They give special packages to a new subscriber only. The existing is not applied for them. Why? Because they want to remain the existing in as their customer, and want to get a new customer from another operators, so that they choose or they give them a better offer or low prices or better packages. Another one, when their rival deviate, so they know when to punish or to begin the punishment. I mean, my rival, when exactly he's going, to deviate or to cheat. So if you do that, I'm ready for the punishment. If you can know that, is good. And also you must be able to successfully punish the rival. If you don't have the resources to do so, then better you do not go to this collusion or type of collusion. especially if your firm size is very small and you don't have economies of scale. So also, factors that affect the collusion is number of firms in the market. If there is fewer firms, easy to punish. If there is so many, it's very difficult. How many companies are going to punish? Are you going to improve your company situation, or you just keep looking and studying others how to punish them? And also, if you know the history of the market, who are the competitors, who are the customers, and also you must know the punishment mechanism, in what way you are going to punish, what tools you are going to use, by stealing their customer, by reducing the prices, by increasing or enhancing the quality, by inventing a new product. So now we come to another theory or game theory. We call it finitely repeated games. So finitely repeated games are games in which a one-shot game is repeated a finite number of times. Variation of finitely repeated games or games in which players do not know when the game will end. It will be played not only one time, several times. It will be going to end, but when we don't know. So know when the game will end is finitely repeated game, and the variation of finitely repeated games in which players do not know when the game will end. Here, the first one, we don't know when the game is end. We're going to be played many times, several times, but we don't know how many times, 5, 6, 7, 8. And or know when the game will be end means we know that we are going to play 5 times, 10 times, 20 times. So let's go for the game with uncertain final period. So we suppose we have two firms, firm A and firm B. Firm M has two strategies, either to lower the price or to increase the price. Firm B is also. So if both of them use or charge low price, they will get 0. If both of them charge high price, they will get 10. If one charge high price, another low price, who charge high will lose 40, who charge low will get 50. So suppose that this game will be played in several times, and the probability that the games will end after a given play is theta, where theta between 0 and 1 means that an uncertain final period mirrors the analysis on infinitely repeated games. So we use the same trigger strategy. So no incentive to cheat on the collusive outcome associated with finitely repeated game with an unknown endpoint above, provided the profit of cheating firm, let's say B, cheat, use low prices, right, equal to 50, this maximum we can get, right? Because the second play, firm A will charge low price, will get 0, 0, so you get 50 maximum. But this 50, if it is less than 10 divided by theta, the probability of the game will be n, equal to pi of corporate. Pi of corporate means that 10. So, how we get this formula? So, we get it here. First, if the firm A does not cheat, so it earns 10 today. In addition, there is a probability of 1 minus theta that the game will be played again. Because theta, the probability to end, 1 minus theta is the probability of playing again. In which case, the firm will earn another 10. So, means there is also probability of 1 minus theta squared 2 or power 2 that the game will not end or terminate after 2 play. In which case A will earn yet another 10. So carrying out this reasoning for a possible date at which the game terminates, we see the firm A can expect to earn if it does not cheat. So, profit of firm A when corporate equal 10, the first, plus 1 minus theta, possibility that the game will not end, times 10, plus 1 minus theta square times 10 for the third, and continue. These all equal, we can write as 10 divided by theta. But if you recall back, if we have this formula in discounted PV, correct? So if we put this 1 minus theta as 1 divided by 1 plus I, so we will have here 10 plus theta, or this 1 minus theta equal to 1 divided by 1 plus I. So 10 times 1 divided by 1 plus I, and continue. And here we give us 10 times 1 plus I divided by I is interest rate, and equal to 10 divided by theta. So this is, we get this formula, we get it from here. Therefore, what is the repeated games with a non-finite period, or end of the period problem? So here, when this game is repeated some non-finite number of time and there is only one Nash equilibrium, is the collusion cannot work. Means we already know the number of times the firm is going to play. So here the collusion would not maybe work. Why? The only equilibrium is a single shot, simultaneous move, Nash equilibrium. In the game above, both firms charge low price. Since I know that this game may be playing is only 5 times, with interest rate maybe 20%. So 5 times automatically, if I play it 5 times, I will get more than 50. Less than 50. And if firm A, so if I get less than 50, means firm, one of them, let's say firm A or B, it has an incentive to cheat. So firm A knows that firm B has an incentive to cheat. Firm B also knows that firm A has an incentive to cheat. Therefore, both of them, they will charge low price and they will get 0-0, and this is the Nash equilibrium. So now we go to another strategy, we call it multistage game theory. So multistage games differ from the previously examined games by examining the timing of decision in games. So player makes sequential rather than simultaneous decision, represented by an extensive form game. So extensive form games are a representation of a game that summarizes the players, the information available to them at each stage, the strategies available to them, the sequence of move, and the payoff resulting from alternative strategies. So we have this. So for firm A, decision node for player A denoting the beginning of the game. Here is the follower. And here the player A pay off 5, and this another 5, player B pay off, or 10, 5, or 15, 5, whatever. So what is player A feasible strategies? So player A either plays up or down. And for player B feasible strategies, it will play up if player A play up, and play down if player play up. Also play up if player A play down, and play down if player A play down. Now, what is the Nash equilibrium? So to illustrate this, or how strategies work in sequence move games, we suppose that player B strategy is to choose down. If player A choose up, then this will choose down. Therefore, and player B will choose down if player A choose down. We just assume that. Given this strategy, what is the best choice by player A? If A chooses up, correct, she in only 5, since we say that B is going to choose down. But if she chooses down, she is going to in 6, since B also chose down. Given a choice between in 5 and 6, player A prefer to 6 to 5. Therefore, player A will choose down. Given that player A chooses down, does player B have an incentive to change his strategy? B strategy specifies that he chooses down if A chooses down. So that we assume that B will choose down. He assumed that A chooses down. And therefore, he can earn 20. Whereas he earns 0 by choosing up. So we thus see that player B has no incentive to change his strategy given that the player A chose down. Since neither player has an incentive to change his or her strategies, we have found a Nash equilibrium in this figure. So the Nash equilibrium, player A will play down and player B will play down if player A chooses up, and play down if player A chooses down. The payoff the result in this equilibrium are 6 for player A and 20 for player B. We may ask whether this is a reasonable outcome for the game. In particular, notice that the highest payoff for A result when A chooses up and B chooses up. Why didn't player A choose up? Because player B threatened to choose down if player A chooses up. Should player A believe this threat? If she chooses up, player B best choice is up since the payoff is 15, which is better for B to choose payoff of 5. But if B chooses up, A earns 10. This higher than the payoff that resulted from the Nash equilibrium we explained earlier. So, what do we make all of this? There is in fact another Nash equilibrium to this game. In particular, suppose player B strategy is to choose up. If player choose up and choose down if player A choose down. Given this strategy by player B, player A earns 10 by choosing up and 6 by choosing down. Clearly, the best response by A to this strategy by up is up. Clearly, the best response by A to this strategy by B is up. Given that player A chooses up, player B has no incentive to change his strategy, and thus we have another Nash equilibrium. In this Nash equilibrium, player A earns 10 and player B earns 15. Now, which of these Nash equilibrium or which of these two Nash equilibrium outcomes is the more reasonable? The answer is no. Player B's strategy involves a non-credible threat since if A plays up, B best response is up too. So, now we come to the subgame perfect equilibrium. Why is it? A condition describing a set of strategies that constitute a Nash equilibrium and allows no player to improve his or own payoff at any stage of the game by changing strategies. So, we have this again, subgame perfect equilibrium. If player A play up, player B also will play up if player A choose up. He will get 15. But he will choose down if player A choose down. He will get 20. Now we got another one which is application of multistage games, which is the entry game. So in this figure, firm B is an existing firm in the market and firm A is a potential entrant. Firm A must decide whether to enter the market in or stay out. If decide to enter or if decide to stay out of the market, firm B continues its existing behavior and earn profit of 10, while A earns 0. But if A decide to enter the market, B decide whether to engage in a price war hard or simply share the market soft. By choosing hard, firm B ensures that firm A incurs a loss of 1 million. But also By choosing hard, firm B ensures that firm A will lose 1 million, but also firm B will make only 1 million. On the other hand, if firm B chooses soft after the enter, means there is no price war, then both firms will get 5-5. It turns out that there are two Nash equilibrium for these games. The first occur where the firm B threatens to choose hard if A enters the market, and thus A stays off the market. To see that these strategies indeed comprise of Nash equilibrium, note the following. Given that firm B's strategy is to choose hard if firm A enters, A's best choice is not to enter. Given that A doesn't enter, B may as well threaten to choose hard if A enter. Thus, either firm had an incentive to change its strategy. Firm A is 0 and firm B earns profit of 10. However, this Nash equilibrium involves a threat that is not credible. The reasons firm A chooses not to enter is that firm B threatens to choose hard if A enters. Does B have an incentive to carry through its threat of choosing hard if A enters? The answer is no. Given that firm A enters to the market, firm B will earn 5 million by choosing soft, but only 1 million by choosing hard. If firm A enters, it is not in firm B's best interest to play hard. Thus, the outcome in which firm A stays out of the market because of firm B threatens to choose hard if it enters is a Nash equilibrium, but it is not a sub-game perfect equilibrium. It involves a threat that is not credible, namely the threat by firm B to engage in a price war if firm A enters. To another Nash equilibrium in this game for firm A to choose in and firm B to follow this move by playing soft. In particular, if firm A enters, firm B best choice is to play soft. So given that firm B plays soft if firm A enters, and A best choice is to enter by choosing in. So A earned 5 million instead of 0. It would end by staying out. This is a subgame perfect equilibrium because it is clearly in firm B's self-interest to play soft whatever A chooses to enter. Thus, while there is two Nash equilibrium for the entry game, there is a unique subgame perfect equilibrium in which firm A chooses in and firm B play soft. So as a conclusion, in one short game resulting payoff are sometimes lower than they would be if players would collude. Players play according to their dominant strategy, which often corresponds to the cheating strategy. If infinitely repeated games, players can collude by using trigger strategies given a sufficiently low interest rate. In infinitely repeated games, players can only use trigger strategies to collude if the players are uncertain as to whom the game ends. In sequential or multistage games, collusion can only be supported when threats are credible. As a conclusion, in one short game, resulting payoff are sometimes lower than they would be if players could collude. Players play according to their dominant strategy, which often correspond to the cheating strategy. In infinitely repeated games, players can collude by using trigger strategies given a sufficiently low interest rate. In infinitely repeated games, players can only use trigger strategies to collude if the players are uncertain as to when the game ends. So I would like to see you in the next video when we discuss about pricing strategies for firms with some power. I hope that you enjoyed this topic and you could use the game theory in your daily managerial decisions. Thank you very much.